Hi, good afternoon, my dear students. Yes, today I would like to discuss most important chapter, continuity and differentiability. So, in a previous year, you have studied relation and function. In this chapter, you have studied for the signum function, rational function, polynomial functions, and other functions, and also limits and derivative. In this expression, so many values how to find out for the continuous. So that base, today I am going to discuss most important value. What do you mean by continuity? How to take the continuity value? Do you know that whenever I can given a consider some instant or some examples are there. Whenever you are going to hospital, so the saline bottle, look at that, the patient how to given that oxygen. So or otherwise they are given for the glucose bottle to given a patient. So drop to drop. Then I hope another way, you know that highway, there of heavy speed, whenever you can take a vehicle at the rate of velocity, at the rate of speed, that instant, you know that is the most exponential, that is the most speed they are considered. So in this one, I am consider one graph. In that expression, how to depend for the continuity. Let us discuss one by one how to consider values. So now most important chapter, continuity and differentiability. Alright. So you can keep observe, I can say to you how to take the values. Alright. On this base, we are going to consider a very simple example. So in this one, I can consider one graph. Alright. So this graph, look at this one. I'm consider some point here. So x-axis here, x dash, here y and y dash. That point I can consider here, right, and another one point consider here. So here that. Look at that graph. The graphs are jumps and breaks. The graphs, you know that there is a jumps and breaks are there, right? Here that words. So similar graph, I hope last year greatest integer function you have studied. Greatest integer function you can consider. So similar manner I can express for the values. Here x dash, here x, so y dash, right? So in this graph goes on the values. Look at this one. The graph here started that line, the points. So many points are there. So the graph, I'm not shifting the pen, I'm not lifting the pen. There is no breaks and no jumps. These two difference. Look at this one. Here a lot of jumps and breaks are there. Here there is no jumps and there is no break. So this is called a common word, discontinuity. Discontinuity. Clear? This one continuity. You can express for the values. So what we are going to say that? How to say that? The graph. Look at that graph. Our breaths are continuously, right? Then we are living. We are alive. So that means whenever the current are flowing continuously instead of this one, keep observe. So at the rate of acceleration, at the rate of speed, you are continuously give that acceleration. It's moving for the vehicle. Whenever you are throwing that rate of time, that is, you know that. So ds by dt, it is called v, velocity, the rate of change of volume, the rate of change of speed. So the rate of change of volume, it is called acceleration, like that. So here, that most important things, applications of physics, now we are going to say that clearly. That means the continuously flowing. What do you mean by continuity? So how to depend for the continuity? So let us discuss the first definition, how to take the value. Here, suppose f is a real function subset of a real number. Suppose f is a real function, real number, real function is a subset of real number and c be the domain of the function, then there exists limit extends to c f of x is equal to f of c. That is called the continuous. Otherwise, it is a discontinuous. The point does not exist, the limit, that is called discontinuity. Or we can express for the values. How to define the values? So, we are going to express for the a very important definition. On this one, right? What do you mean by continuity? Suppose f is a real function subset of real number, and let C be the domain of the function, then there exist limits, right? So most important, limit extends to c f of x is equal to f of c. So that is the most important value, f of c. So this is called the limit. So already you have studied in the first year the coincide, right hand side, left hand side, right hand limit, left hand limit, they are also coincide, which is having for the limit exist. On this base we are continuing one simple example. Check the continuity of the function, right? Check the continuity of the function. F of x is equal to 2x plus 3 at x is equal to 1. So how to prove that? How to check it that values? So this is, you know that it is a polynomial function or simple linear polynomial function like that. So in this one, we are going to express for the limit solution. So given limit x tends to 1, so f of x limit x tends to 1, so 2x plus 3, applying the limit. So in this one, 2 of 1 plus 3, so 2 of plus 3, so got it, fine, applying the limit. So and also you know that we are not going to applying the limit. F of x is equal to 2x plus 3 at x is equal to 1, so f of 1, so 2 of 1 plus 3, so this is a 5. So therefore f is continuous at x is equal to 1, hence a required equation. So now we are going to find out another few example in that next class. So how to find out for the signum function, 2 to 3 values of signum function, greatest integers functions, and some other functions. We are going to find out for the how to prove that one greatest, find out for lambda value, a and b value, and how to relation between a and b. In that next section we have discussed. Thank you so much. Please, most important all these. Bye. Thank you.